students, and welcome to this video. The purpose of this particular module is to introduce you to the concept of scientific notation. So we are now in lesson 1-7 about scientific notation. Scientific notation is a special way of writing numbers. Essentially, we utilize scientific notation whenever we're dealing with really large numbers or really small numbers. Whenever we're dealing with these really big or small values and we write things in scientific notation, it makes it a little more manageable. It also kind of makes it easier to understand what number you're talking about, and it's just more efficient to utilize. So, for example, if I had the number 700, which I'd probably never write this in scientific notation, but, providing you with a number that's just a little more reasonable starting out with. Writing 700 in scientific notation would be 7 times 10 to the second. So in scientific notation, essentially you're trying to get rid of the zeros, so the unnecessary zeros. When you have a bunch of zeros coming after or before a particular number, the times 10 represents those zeros, and then your exponent tells you how many zeros you got rid of. So if you notice 700, that's a whole number and the decimal's at the end. If I were to move that decimal 2 places to the left, it would be 7 and then the decimal place. And so I would have gotten rid of the 2 zeros. And that's why when I write that in scientific notation, it's just 7 times 10 to the second, because I moved 2 places to the left. Same thing with this 4,900,000,000 number that's below the 700. If I count up those numbers of zeros, there's 1, 2, 3, 4, 5, 6, 7, 8. Now, if you'll notice in scientific notation, we have times 10 to the 9th. And the reason why is because we actually moved the decimal between the 4 and the 9 as well. So in scientific notation, different books will word this differently, but essentially, you're trying to put one number on the left and then the decimal and then the rest of the numbers, non-zero numbers, on the right-hand side. So generally, it will always be, a number, point, and then a number if there is one. So how does this work? Again, you're always multiplying by 10, and then you're raising it to the specific power. Excuse me, I'm so sorry. Whew, I couldn't control that yawn. I apologize. You're raising it to an exponent based off of the number of zeros that you're getting rid of. So how to convert in scientific notation. So you see this value here. This is 326 billion. And it says move the decimal point so that it is between the first 2 significant digits. Again, remember that means have a number, decimal, and then all the non-zero numbers after that. So if I count up the number of zeros that I have, they're 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 zeros. And zeros are considered non-significant values. So I know that I'm moving the decimal place at least 9. But I want it between the first 2 significant digits. So I'm also going to move it in front of the 6. And I'm also going to move it in front of the 2, because significant values are anything other than 0. So I moved it the 9 places to the left over across those 9 zeros, and then I moved it 2 more places across my significant value. Therefore, the final solution should be 3.26 times 10 to the 11th power. Now, sometimes we'll move our decimal point the other direction. So in all these examples I've shown you, we've been moving to the left, and sometimes you'll move to the right. If you have to move your decimal to the right, your exponent is negative. This means you start out with a really small number, like 0.0021. Since you have 0.00 first and then the numbers 21, you would need to move to the right. Whereas when we move to the left, like in a value 700, the zeros are on the end, so we're skipping over those zeros going in the left direction. So I encourage you to attempt to solve these final examples, and you can pause this video as I will provide you with the solutions. So looking at letter A, I have 0.004694, and I want to get my decimal in between the first two significant values. So those zeros are non-significant, but that 4 and the 6 would be my first two significant values. And so I want to get the decimal between the 4 and the 6. So that means to the right, I'm going to move 1, 2, 3 places. Since I'm moving to the right, that would be a -3. So my final answer should be 4.694 times 10 to the -3rd power. On letter B, my decimal is already in between the first two significant values. Therefore, I don't need to do anything to this particular problem. And looking at letter C, I have 4,679,000. So the decimal is on the very end. So I want to move it past the 3 zeros. And I actually need to get the decimal between the 4 and the 6. So it means I need to pass the 9 and the 7 and then the 6. And I'm going to the left. So it's a positive exponent of 6 places. So my final answer would be 4.679 times 10 to the +6th power. I hope that you found this video helpful. As always, if there's any questions or concerns, please don't hesitate to reach out to me for further assistance.